Hello, my name is Kelsey Cameron, and today I will explain to you how classful addressing works and how subnets are created within IP addresses. So, first thing that's important to know is that IP addresses are composed of 32 bits. 32 bits. Now, it's also important to keep in mind that in this world, byte addressability is something that's really important. Most of our devices can handle that a lot better. And basically, it was kind of arbitrarily decided that data would be broken up into bytes. So we know that 1 byte is 8 bits. So 32 bits is 4 bytes. That will be important in what I'm about to explain next. 32 bits is 4 bytes. So, now I'd like to talk about the different classes of addressing. You have 5 classes technically, but I'm only going to go over 3 of them. Class A, Class B, and Class C. These classes are a way of dividing up networks versus hosts using the 32 available bits, and different classes are needed in different scenarios. So the way that these are organized, basically Class A has 8 bits for networks, and 24 bits for hosts. See that /24? That might come up again. If you see a /24 at the end of something, it basically means this is how many bits are reserved for the host. Class B, you have an equal amount for both, so 16 bits for networks, and 16 bits for hosts. There it is again, /16. And for Class C, you have 24 bits for networks, and then 8 bits for hosts. Again. So, based on this, what class would you use if you have a ton of different networks? You have a ton of networks. Think like every network in the whole world. What class do you think you would use? Well, you would use Class C. And that's actually why Class C is one of the most popular ones, because there's 2 to the 21 available networks. I'm going to explain why this is 21 and not 24 now. On a new page. So basically, Class A has a leading bit of 0. That means that this 0 is fixed, cannot be moved at all. So I'm going to show you how to get the class ranges, the address ranges for each of these classes. So we know that that 0 can't be changed. And if that 0 can't be changed, and I know for Class A, I have 8 bits for an address, or 8 bits of an address for network, that means that I could have another bit here, another here, 1, 2, 3, 4. Because I have, that was 8/24. I have 16 for Class B, and then I have 8 for Class C. So these different classes are basically a level of organization to divide up hosts and to divide up networks. So there's actually another thing called CIDR that lets you custom choose how many networks you want versus hosts, but this isn't as widely used, both because it's not separated into different bytes, and because whoever you're sending the data to would also need to understand that division. So that's why these are the main classes. So in this case, 0 is fixed. So what does that mean about Class A? For that first number in an IP address, how many options do you have here? Well, you have 2 to the 7th, because you have 1 here that could be two values, times 2, times 2, times 2, 7 times. So that means there's 2 to the 7th possibilities. That means there's 2 to the 7th networks. So imagine, and so what is 2 to the 7th? Do you guys know? Well, 2 to the 7th is 128. But you got to remember that it's actually minus 1 because you start counting from 0. So if this was a 1 here, if this was a 1, and that was a 1, 1, 1, 1, 1, 1. This number right here, 0, 1, 1, 1, 7 times here, that number is actually 127. So the first number for class A, the minimum is 0, and it goes all the way to 127. Naturally, where class A ends is where class B starts. So class B actually has a fixed bit of 1, 0. So these two are fixed. Well, in class B, we know we have 16 networks and 16 hosts. So that means I have 16-bit choices. So this is 1, 2. And how many do I have remaining? 16 minus 2 is 14. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This means that I have 2 to the 14 networks to work with. Why is it not 2 to the 16? It's not 2 to the 16 because these 2 bits are fixed. They're fixed because it tells the other receiving end, this is a class B, this is a class A, this is a class C. It is basically a message to say, this is how I have decided to divide up my data. But they did it in a way that makes sense. So if you look at the address range here, for the first number, basically the second 8 of these can be ignored because I'm only talking about the first number. 1, 2, 3, 4, 5, 6, 7, 8. So there we go, just ignore that for now. So what is this number here? If all of these were zeros, what is that minimum number? Well, that minimum number is actually right where class A ends. So it's 128. Through, what if all of these were ones? 1, 0, 1, 1, 1, 1, 1, 1. Well, that number is actually 223. So, where do you think class C starts? Let's see if you guessed it right. It starts at 224. Why does it start at 224? Because the next fixed bit is 110. Do you notice the pattern here? You have 0, then you have 10, then you have 110. All you're doing each time is adding another set bit to the front. So class B, which I won't go over, would be a 1110. And class E would be 11110. And that gives you the different flexibility that you need. Class B and E are not as common, so I won't talk about them very much, but this goes from 224 all the way to, let's see, this number in binary, which in this case, that number is, oh, whoops, I did the wrong calculation. Sorry about that, guys. Sorry, this number right here in binary is actually 191. This number right here. So that's 128 to 191, and then this would be 192 to 223. And if you want to confirm all of this, you can just add up all the different numbers, like 1 plus 2 plus 4 plus 8 plus 16 plus 64 plus 128, and this is your max value. Now that class A goes from 0, 0, 0, 0, 0, 8 zeros, 8, all the way to 0 and then 7 ones. So that's A. And then we know that B goes from 16 zeros because it's 16 and 16. So this is, like I said, 0 to 127. So for class B, if I have 1, 0 fixed, all of these are 0, 0, 0, 0, 0, 8, 2, 1, 2, 3, 4, 5, 6, 7, 8, which is 128 to 191. And then for class C, you have 1, 1, 0, and then all zeros, 2, 3, with the first number. Technically, because you have more than 8 bits to use for the Class B network, this is actually 101111111 dot 1111111 8 ones. So this actually can go from 128.255 to 191. Yeah, 128.0 to 191.255. So that means for the second number, you can either go from 0 to 255. You have all of those choices, because these are all free bits to use. And then for a Class C address, you have even more of that, because you have 24 possible network choices. So hopefully that explains a little bit about how that works. Basically, from one class to another, you just add another set bit in front, and that will give you more options within your different class division. Remember that this is all in terms of bytes, because byte addressability is very common, and that's at least what I think the reason is for this type of organization. So now I'm going to give you an example problem, and I'm going to explain how to solve it, how it works, and maybe a few things that will help you remember it. So first I'll read you the problem. Suppose a company received the following IP network number: 221.163.175.0. You want to set up the company's network to limit the number of hosts on each subnet to approximately 60. So I need 60 hosts. So from this problem, you're probably wondering, what is a subnet? Why do I care? Well, a subnet is a way of dividing up all of your address space so it can all be used. Imagine a company that needs, let's say a company that wanted to use, 2 to the 9th networks, but they didn't want to use a Class B. Instead, they wanted to use multiple Class A's. So subnetting would help with that, because it basically lets you stop wasting address space and split up everything so that it can be used in different ways. So instead of, with a Class C, the 24/8 that I was talking about, 24/8, if you were a company and you chose a Class C address and you only needed it for like 10 people, 10 hosts, then you'd be wasting 2 to the 8th minus 10. That's a lot of wasted space. It really is. So a way that this can be remedied is by adding subnets. So you can basically pass it into different departments, and multiple of the similar addresses could be reused. So let's say normally you couldn't have double addresses like 111 and then another 111. But if you had a subnet, you could have a 0 here and a 1 here. Then that makes them unique addresses, and they can both be used. So that explains the importance of how subnets prevent wasting of address space. So now I'm going to actually answer this question. So first off, what class is this? This IP address, 221.163.175.0. Well, I don't know if you remember these ranges or not, but I will go ahead and tell you the ranges again. Class A is from 0 to 127. Class B is from 128 to 191. And this is all because of the set bits that I just explained. And then 192 to 223. So this first number, which category does it belong to here? A, B, or C? The answer is C, because 221 is within this range. So this is a Class C network. Hopefully that makes sense. If that doesn't make sense, you might want to go back and watch the previous part of this video. And so now the next question is, if I need 60 hosts, how many bits do I need to represent 60? Well, you could either take log base 2 of 60 to figure that out, or you could think, okay, what power of 2 will give me at least 60 individual hosts? So you do the math. 2 to the first is 2, 2 to the second is 4. You go through it all, and you discover that 2 to the 6 is equal to 64. This means that you need at least 6 bits to represent 64 hosts. This is actually 62 usable, which I will explain. So you need 6 bits to represent 64 hosts. So if we know that we need 6 bits to represent 64 hosts, well, for a Class C address, how many hosts do we have? How many bits do we have available to represent the hosts? Remember how I told you a Class C network had this distinction here, 24/8? This means that 24 bits are used to represent the network, and 8 bits are used to represent the host. So that means I have 8 bits in total that I can work with. And it's common practice that when you're creating subnets, that the subnet ID comes first. So that means your line here should be after the sixth bit here. So 1, 2, 3, 4, 5, 6. Here we go, right there. So that means this whole part of it will be the subnet ID. And then this can be the data, or the address. The exact address that you want to use. So, based on that, I'm going to rewrite this and get a new sketch just so I have some more room to work with. So it was 221.163.175.0, and I know that I need 6 bits to represent 60 hosts. So if I need 6 bits for that, how many bits do I have remaining? I have 2. So if I need 6 bits, oh, I actually messed up the order in that last example. I'll redraw it here. 1, 2, 3, 4, 5, 6, 7, 8. So actually, I put the line in the wrong place. So I'm sorry about that. So like I said, the subnet ID should come first. So right here, this should be your particular subnet that you're using. And then this would be all of the unique identifiers. So the line would actually be right there. Sorry about that. So that means that if I have 6 bits to represent 60 hosts, how many bits do I have to create subnets with? Well, I know I have 8 bits total, and minus 6 bits for the subnet ID, for the subnet the individual subnet. That means I have 2 bits remaining for my subnet. If I have 2 bits, how many subnets will that give me? 2 bits, 2 to the 2. That means 2 bits means 2 squared, which is 4 subnets. So that means that I have 4 subnets required in order to have enough space to support 60 hosts on each subnet. Hopefully that makes sense. I'm going to keep going into the ranges, and maybe it will clarify a little bit. So in this question, it asks how many subnets are required, and that answer is 4 subnets. 4 subnets are required because you need the remaining 6 bits to support the 60 hosts per subnet. And if you have 60 hosts per subnet, that you remember you're always trying to save space. You don't want to use more bits than you need. So you have 6 to represent each host, 6 bits for each host, and then 2 bits remaining for the amount of subnets. So 2 squared is 4 subnets. And the second question, how many bits must be borrowed from the host bits to be used for the subnet ID? Well, like I said, the subnet ID is going to be 2 bits. So now the question is, what is the subnet mask? So the subnet mask, we know that this is a Class C network. So if I want to figure out what my subnet mask is, I need to make sure that all of my hosts are zeroed out, but everything else has 1s. So the distinction here, I know that I don't want to completely get rid of the network. So I have to have 11111111.11111111.1111 81s. Now is the harder part. This is a Class C network, and I just mentioned that 2 of those 8 bits, 1, 2, 3, 4, 5, 6, 7, 8, these 2 are going to represent the subnet ID, which subnet you're using. So if those are your subnet ID, then if you want to get the subnet mask, then you would have to set those bits to 1. So this would be 1, 1, 0, 0, 0, 0, 0, 0. The reason that you set these all to 0 is because you're only trying to get the subnet ID. You're not trying to get which host you're on. You're not trying to get the network. You're trying to get exactly which subnet, like where it starts, basically. You're trying to get the starting point for each subnet. 0, subnet 1, subnet 2, subnet 3, subnet 4. You need to get all of those starting points. So if you put this in decimal form, this is 255.255.255.192. But as you probably can recognize, these zeros could all be different hosts. So this is really 192 all the way up. So if you AND this value, if you logically AND this with whatever your IP address is, it will tell you the host, or it will tell you the subnet ID that you're using because of these 2 ones. So now I'm going to list the different address ranges for each subnet. And I'm going to rewrite the IP address that we started with. So we know now that we have to have 4 subnets in order to support 60 hosts per subnet. So we have 4 subnets and IP address 221.163.175.0. Remember that this is 24/8, which means 24 network bits and 8 host bits. But we subnetted this, so we know that this is actually kind of more like 24/2/8, or /6, 24/2/6. No one actually writes it like this, but this is just something that's helpful for me to visualize it. 2 being the subnet ID, and then 6 being your host ID. And then 24 being your network ID. So hopefully that shows you the level of organization that you need. And if we wanted to get the different address ranges, we know that we can't change the network because this is all on the same network. So all of these values, this whole thing, has to be fixed. That means for all of my address ranges in each subnet, this does not change. It can't change because all of the subnets are on the same network. So hopefully that makes sense. But I know that this 0, this can go all the way up to what value? Well, it can go from 0 to 255 with a few caveats there, which I'll explain in the next slide here. So it can go from 0 to 255. If I need 4 subnets, how would I divide this? I have 255 possible values and I have 4 subnets. Well, logically, you'd want to break it into 4s, right? Right. But it's actually a little bit more complex than that. So I'm going to show you in binary how this works, because binary is very helpful for understanding networks. So remember how I told you that 2 of these bits are for the subnet ID and the other 6 are for the host ID? Well, you have 8 possible bits. 1, 2, 3, 4. If I have 4 subnets, that means that I have 4 possible values. I have 0, 0, I have 0, 1, I have 1, 0, and then I have 1, 1. And everything else, this could all be 0, or it could all be 1. This could all be 0, this could all be 1, this could all be 0, this could all be 1, and this could all be 0, this could all be 1. So that's how you're going to get the min and max ranges for each subnet. But something very important to keep in mind is that you can't actually use all zeros or all ones in these. Why not? Because the zeros, if this was all 0, this would represent the ID of your subnet. Just the ID, nothing else. And if this was all 1, this would represent the broadcasting address. So I actually have a different range than you would expect. I'm going to erase these lines. my range is actually not from 0, 0, 0, 0 all the way to the other ones. It's actually 0, 0, 0, 0, 0, 1 through 0, 0, and this 0, 0 is fixed because I'm in subnet 0 right now. 0, 0, 1, 1, 1. 0, 0, 1, 1. Trying to get to 8 here. Wait a sec. There we go. That's better. Yeah, 1, 1, 0. So this is the host part of the IP address. So it actually goes from 0, 0, 0, 0, 1 through all this, except that this last digit is a 0. If this last digit was a 1, that would be the broadcasting address, and the broadcasting address is not allowed because it's not a usable host. So, and the same applies for all of the other subnets. It's really important to understand that you can't just do one thing for one subnet and then do something different for the others. So here are the values. 0, 1, 1, 1, 1, 1, 0. And remember, this 0, 1 is fixed because I'm in subnet 1. And then this 1, 0 is fixed because I'm in subnet 2. And then this 1, 1 is fixed because I'm in subnet 3. These are the min and max ranges. So this would be min. This is max. Convert this all to decimal, you get that the usable address ranges are 221.163.175 through .1, it's .1 because I can't use the subnet ID as a host, through 221.163.175.62. Why is it not 63? Because I can't use the broadcasting address. And then this is for the subnet 0. And then for subnet 1, 1, 2, and 3. This would be 221.163.175.64 through 221.163.175.126. Why is it not 63 and 127? Same reason. You can't have a subnet ID as a host, and you can't have a broadcasting address either. Notice the fact that these are all the same. In every single one of these, that all of the network bits are staying the same. It can't change because you're all in the same network. All of these subnets are in one network, so it wouldn't make sense for that to change. So then for subnet 3, 163.175.128 through 221.163.175.190. Why is it not 191? Because you can't use the broadcasting address. 221.163.175.192 through 221.163.175.254, I believe. Let me see here. Let me double check in that other save. I'm going to save that. So all these values that I wrote here are just the binary translations. If this was all 1, that would be 255. And then it's -1, so that's 254. So you see that this on the left is just the decimal part on the left, and then on the right is just the binary part. Hopefully that becomes straightforward when I show you this view. So these are my address ranges. Remember, the network does not change. Remember that you can't use all zeros or all ones within the host because it's both the subnet ID and the broadcasting address. So that means, remember when I told you I'd explain what I meant when I said that there were 62 usable instead of 64? Well, that was because of what I just explained. I can't use all of the host bits, so that's why, even though that there were 8 choices, 8 bits, 8 to 8 is 64, I had to subtract 2 from that because I can't use the subnet ID or the broadcasting address, and then that for those 6 bits. I'm sorry, I said 8 bits just now. I meant 6. So 2 to the 6 equals 64. But I can't use all 64 of those choices because those are all of the individual host identifiers, and I can't do 0, 0, 0, 0, 0, 0, and I can't do 1, 1, 1, 1, 1, 1. So those are 2 choices that are not allowed. Hopefully that makes sense to you. If you have any questions, feel free to ask me. Also, I'm going to explain one last thing before I end this video, and I really hope you enjoyed it. I've been seriously trying to find some good subnetting videos on this on YouTube, and I have not found a lot of good resources, so hopefully this clarifies a few things. And to conclude, I will explain what are these drawbacks. Classful addressing is basically what this is called, where you are separating your addresses into different classes, Class A, Class B, Class C. The drawbacks are that within your organization, you're going to have, most likely, this Class A or Class B, Class C, none of those classes are going to accurately reflect your organization within your network. So let's say you're a big company, and you need this amount. The likelihood that you're going to need exactly 2 to the 16th networks, and not more, not less than that, is very slim. That leads me to my next point. This also wastes a lot of address space, which as I've shown you here, subnets take care of that because it lets you fix that by using almost all of the address space, kind of as much of it as you want, depending on how many hosts you need per subnet. And then the drawbacks without subnetting. The drawbacks to classful addressing are that there's an increasing demand for IP addresses at this point in time, and the more networks we have, the more unique identifiers we'll need, and eventually 32 bits isn't going to be enough. But one way to fix that is IPv6, where there's just more bits to use. And yeah, I hope this makes sense to you. I hope you enjoyed the video, and let me know if you have any questions. Have a great day.